Alright, hello chemistry students. I wanted to film this short video to tell you a little bit about activity series, which is the other concept that we were working on in lab over the past couple of days, but we haven't really gotten to the end to the payoff. That will be what we do in class tomorrow. So I wanted to introduce the concept before we got there. So an activity series is based on the concept that just because we can write a chemical reaction for we can write a chemical reaction occurring does not mean that it's guaranteed to occur if we mix those chemicals in the lab. We'll figure out why later on, and it's all based on reaction energies and things like that. But we can start to get a concept for this based on this thing called the activity series of metals. So the concept is just because we can write a single replacement reaction, just because a single replacement reaction can occur, does not mean that it will occur if we mix the chemicals. And the rule that governs this is that metals that are listed as more active on the activity series will react with less active metal salts. However, the reverse reaction will not occur. What do I mean by that? Let's take a look at an example. So here, we have a single replacement reaction that we've written out for nickel metal reacting with copper nitrate to produce copper and nickel nitrate. Nickel's coming in and kicking out the copper. Now, this reaction can be written. We can also write the exact reverse reaction, which is copper replacing nickel in nickel nitrate to form solid nickel and copper nitrate. Now, logic dictates that only one of these reactions can occur, because if we were able to form copper on the surface of our nickel when we mix copper nitrate with nickel, and the reverse reaction was able to occur, then nothing would happen. We would have nickel forming copper, copper forming nickel, and the exchange would be roughly even. So we wouldn't really see any change. However, when we actually mix these chemicals, we would expect one of these reactions to occur, and one of these reactions to have no reaction once we actually do this. And the thing that predicts that is which of these two metals, nickel or copper, is more active. Well, let's go ahead and find that out. I have some nickel, and I'm going to add it to my well plate, and I have a solution of copper nitrate, just right here. So if I add copper nitrate to this nickel, since I believe nickel is a more active metal, we should see some level of reaction occurring. And I'm going to completely coat this nickel to see if we can elicit a reaction here. However, if we do the reverse and we take copper metal and react it with nickel nitrate, let me just take a little bit of copper shot here. Should have grabbed my tweezers before I came in. I grab a little piece of copper shot and add some nickel nitrate to it. We shouldn't have any reaction occur there because copper is a less active metal than nickel. So again, we're adding nickel nitrate right here. So we'll take a little look at these metals after a couple of minutes and see what has happened to them. I think I'm already seeing a little bit of change with this nickel. So let me see if I can't pull it out here. And voila. What we see is this piece of nickel is very different than the nickel that we started with. In fact, there's a layer of copper deposited on the surface of the nickel. I'll set these both down in the well plates so that you can see the difference. If we look at these, we see one has that copper kind of brown sheen to it, and this one is completely silvery like nickel metal typically is. So This reaction, nickel with copper nitrate, was able to occur. This reaction was not. This proves that nickel is a more active metal than copper. All right, looks like I'm running to the end of the period. I'll let you go. I didn't bring my tweezers, so don't try that at home. Never put your gloves into chemicals. I will refilm this video for future classes with that edited out. So thank you very much. Take care. Have a good one.